Thank you. Well, seriously, part of the reason I didn't, because I tried to make this sort of a recap of what is going on here. Thank you very much, Rupert, for putting this together. It really is great. And Sarah, thank you for all the work you did. Can you hear me all okay? Okay. So I did want to make this a little bit lighter. This has been a pretty heavy 3 days, but to make this sort of capture what we've learned from our experience with ketamine, and not so much the specifics about each individual thing, but what we've learned about the whole process of developing a new treatment such as ketamine and some of the unexpected lessons we've learned. I do consult to many companies and research contracts with several, and I do have equity in Biohaven Pharmaceuticals. Those are my main conflicts. But first, just to start with the overarching lesson. I mean, we always talk about translational medicine, and I think if nothing else, if we look at it, the biggest lesson that we've learned from this is that the path, for preclinical discovery of leading to true clinical advances is winding. There's frequent dead ends, merges, and switchbacks. It's definitely not a direct line, and I think ketamine really highlights that. But from an important perspective, I think is we're at kind of a critical point in how we're funding medicine and how we're funding translational medicine. And now this slide is already going on 10 years old, I think, but it's starting to become more and more of an issue of, are we putting our money in the right places, especially the large governmental agencies like the NIH and where we're putting money. And if you actually see this large gap, but specifically if you look down there on the right, that they call the translational gap, you could see as the research funding has gone up and up and up from the NIH, especially going more to PhD researchers. And I am an MD PhD, so I feel okay saying this. And really MD and MD PhD has not really increased. We see that the expenditure has gone way up, but the actual new molecular entity output has not really kept up with the expenditure. So it's an interesting thing, and it means as we're getting further and further away from the clinic, we may not be getting more successful in developing compounds. So just something for us to be aware of. And then we start to identify, well, what are some of the hazards in this large gap that's generating this large translational gap? And, people have been looking at this for quite a while, and I've identified several things. And I think we could take away from our lessons with ketamine some specific ones, really highlighting, how do we think about the underlying hypotheses and how that leads our research, the reproducibility, the incentives, the follow through, and how we start to think about that. The regulatory aspects, how we approach that. And I think ketamine more than anything has highlighted some unintended consequences here, and where the funding comes from. And then also the problems with collaboration, or I'd say the lack of collaboration. So hopefully we'll touch on some of those. But just to start with the fundamental hypothesis. This will be lessons 1A and 1B is, sometimes the basic science can at least lead you to the right haystack, but you need serendipity to actually find the needle. I think that's a fair thing to say. So for ketamine, for the decade or 2 decades leading up to that first study in depression, there was increasing evidence that the pathophysiology of depression or the pathogenesis went well beyond the monoaminergic system. There was increasing evidence that there was true cytoarchitectural abnormalities in the brain, specifically glial cells and some other neuronal components in the brain, but largely in the anterior cingulate, not in the raphe or other primary serotonergic zones where you would consider. There was increasing evidence to suggest that the glutamatergic system was contributing significantly to stress-induced pathology. So there was that basic growing evidence there. And then Phil Skolnick's lab at the NIH really started to show some evidence that the NMDA receptor specifically may have some role in the pathogenesis of depression, and it may be a viable target for antidepressant drug development. So this is really from the 80s through the 90s that there was increasing development. I personally got involved in this from work starting to suggest that there are abnormal levels of GABA and glutamate in the brain really happening at the turn of the millennia, more evidence of that. But the reality of what led to that first study, and Rob is here, so Rob can speak for himself, but this is a quote from John Crystal that was in the paper we wrote in Neuron a few years ago. And the underlying idea was, let's try ketamine. Let's see what happens if you target the glutamatergic system. And the exact quote is, if one viewed depression as a disorder of the cortical limbic function, then glutamatergic and GABAergic signaling would be implicated. This perspective shift led us to test the effects of the NMDA glutamate receptor antagonist as a probe to alterations in glutamate signaling associated with depression. And Rob, I think you said it wasn't so much even the idea that I was going to get depression better. It was to see if they would be more sensitive to the perturbation of the glutamatergic system. Depressed patients would have an increased sensitivity. So the finding that everybody is well aware of right now, that first study showing a large difference in this crossover study between getting a placebo, which was saline, or 0.5 mg IV over 40 minutes of ketamine that had this rapid response and it's become this iconic figure right now. This was John Crystal's quote, and Rob, you could add your own here, but to the amazement of our patients and ourselves, we found that ketamine produced rapid, profound, and surprisingly durable antidepressant effects that were temporarily dissociated from the brief acute behavioral effects of the drug. So this wasn't a real anticipated finding. I think, and feel funny, Rob is right back there and the other people doing this, but Rob, I think you can speak up and say, this wasn't the primary hypothesis. You weren't thinking you're gonna have a great antidepressant response. It was serendipity. But you were playing in the right sandbox by knowing that you're targeting something that had glutamatergic effects at least. So lesson 2 that I come, which I think is one of the major lessons that we tend to, I think, forget came out of this, is the onset of antidepressant response does not require months or weeks to months. And really, if you just go back, this is, Elliot Rickelson just in the early 2000s, 2001, basically writing it as it was a given, that we just accept the fact that all antidepressants take that long and there's nothing that's different. Maybe sleep deprivation for a day, but that was it. It was just a given. And even as recently as March 2022, the NIH webpage still basically says antidepressants normally will take 4 to 8 weeks. It was just a given prior to ketamine. Now I can write lists of rapid-acting antidepressants, or at least proposed rapid-acting antidepressants, but some that are really showing good evidence. We all know brexanolone now, single administration in postpartum depression. Nice evidence, FDA approval with results in hours. The more recent protocols with some of the theta burst stimulation for TMS and the recent protocol out of Stanford suggesting this rapid onset of effects, and more of these studies suggesting that you can have rapid onset of antidepressant, the psychedelics. So this idea has really changed, and I think we kind of forget about that prior to ketamine, that really wasn't a consideration. Lesson 3, that some of these potentially groundbreaking discoveries just wither on the branch. So this wasn't the first time. There was a study actually out of Iran in the early 1970s suggesting that ketamine, and remarkably, they kind of arrived at 0.5 mg per kg too, which was pretty interesting, had this response in their patients. They weren't depressed patients necessarily, they were just hospitalized patients, but they had this tremendous response. They were actually looking at abreaction, which is a psychodynamic principle that I have no idea what it means, but they were coming at it from a psychodynamic perspective and thought that ketamine would have an effect there. And they had pretty remarkable results, just died on the branch, that wasn't followed up on. And then even some preclinical work, coming out of Wallace Laboratories, showing ketamine to have a signal as an antidepressant, but nobody really picked up on that. It took 6 years before the next paper came out. That was the paper by Carlos and Dennis Charney and others at the NIH replicating the finding. So we went from 7 people to 18 people, but still small, but replicated it. Very consistent and very similar results. But 6 years later, and you question if they would have spent more time in the clinic and the lab instead of the pub, we probably would have got there a little quicker. But but not only it took 6 years to get there, then it took another almost 15 years before you had this small grouping of clinical trials that showed consistency over time. And this is really slow progress from a finding that seemed incredible, and maybe that was the reason it took so long. It seemed a little too incredible. But from this finding to be replicated once took 6 years, and then to actually show enough data that people could start to really believe in it took 15 years. That it says something about how we're doing things from an academic perspective. Personally, I took another lesson from this. This is my lesson 5. Sometimes it's just wise to keep it simple in replicating it. So Carlos's paper came out in 2006. He started recruiting for it in 2005, something he said, 2004. We started in 2004 recruiting for a study to replicate this. But we had this idea that we're going to do 7 magnetic resonance spectroscopy studies because we were going to figure out the mechanism of the 7 people without trying to replicate it. We were convinced that there's 7 people, so now we have to figure out how it worked. It took us years to do this study. And you all know this Valentine paper, right? It's well known, just like the Zarate paper, right? I'm joking. Nobody knows this paper. This is the common sense would have been to just replicate your data, and really do it in a way that's believable. I think in academics, we tend to start to get ahead of ourselves, start to look for mechanisms of action, start to look for functions, start to do all these other studies. We're never just satisfied with replicating data, which is actually really the most important thing. All right. Lesson 6, and this is probably the main one that I learned, at least. Translational or biomedical science, especially clinical trials, is really expensive and really slow. So there were findings going back, this is Ron Duman's paper from 2010, suggesting that there was a dose response curve. If you gave higher doses, the animals didn't have that antidepressant-like response. They didn't have the changes in their mTORC-C1 phosphorylation. We went back and we were able to replicate that we didn't see the glutamate-glutamine cycling. As you increase the dose, we had a dose response curve up to a certain point and then it disappears. And again, could replicate in the animal models that we no longer saw any changes that would be reminiscent of an antidepressant response. And even before that, 20 years ago, Beta Mogadam was showing microdialysis studies showing that there's a real strong dose-related effect. And once you went above, in the rodents about 30 mg per kg, once you went into the range that was getting towards that near anesthetic dose, you actually decreased glutamate release, not increased it. So there was evidence for a long time that this could be an inverted U shape, that there could be a dose could really matter, and largely Cmax. But with that, just to do any dose-finding study in an academic situation took years until this was the RAPID study that was funded by the NIMH, which was looking at 4 different doses versus midazolam. And it took us almost 4 years to do this study after waiting 10, 15 years to get it started. And then even with this, with 4 years, 4 or 5 major academic sites, we're still underpowered. We really didn't have much to say from this study. Clearly this is the 0.5 mg per kg dose seemed to do better. This is 1, but this is the 1 mg per kg. But then if you look at the 0.2 was actually up here and 0.1 was there and midazolam was there. So you really couldn't say that much. That's because we're underpowered. There's about 20 people per group, 5 groups. And then also it took years, and it actually took funding from Janssen to replicate just multiple dosing in a randomized placebo-controlled trial that had an N big enough to really kind of be believable. And then to try to identify how many times a week you should dose. So this was a simple study where you were randomized first to either be treated 3 times a week or 2 times a week. And then within that, you were randomized again, whether to get active or placebo, whether it was 0.5 mg per kg IV or saline. So you saw the results of that. But now, I mean, you're talking about publications now, 2016, just to do a simple study like this. And it required industry funding to get us there. So the next lesson I want to say is there are probably better ways of expediting the process. And some of the stuff that we're seeing, I think, is giving us ideas on how to do that. We knew we wrote in 2016, published in 2017, we did a survey of the places in North America, largely in the US, but some in Canada, that were using ketamine treatments. And we just asked them how they were performing their treatments. And we looked at the rate of growth. And at that time, there was an estimate that maybe about 10,000 people had been treated. It's a pretty large number considering all those studies up there had ends of 17, 16. The biggest had 69 people. I mean, we lose so much valuable data because we weren't collecting it in any consistent manner. It's kind of scary to think of how much we're not learning by not having any control. I was really glad to see the studies by Puya, who is here, presented his ECT data, which is great, and Allison was here, and I mean, starting to present real world data, I think is so important. And finding ways of collaborating together to collect this data, I think is really going to be critical, not only for ketamine, but for any new treatments that come out. We know the RCTs are great, but they take a long time, they're very expensive, and you don't really get that real world data that's so critical. So hopefully one of the things we can do is figure out ways of working together. I do want to add that with lesson 7.5, which is my favorite book. If you guys don't have this, go buy this book. It's Richard Harris is a science writer for NPR. I have no connection to him, get no royalties, but it is a great book talking about the real pitfalls of biomedical science. And he starts out by saying he's a huge fan of biomedical science. And unfortunately, it came out at a terrible time in the US. It came out right in 2016 when there was a big anti-science movement in the US. And this kind of came out at that time. It wasn't his intent. He made it very clear that the problem with biomedical science is we don't give enough funding to it and we take too many shortcuts. And that's where the real issue is. But the timing could have been a little bit better for us, but it is really important. And the key point here is if we're gonna do the science, we do have to keep the rigor. And Allison, we were just even talking about measures when you do the real world studies, like using the quids. We use the quids too. I'm not sure that unless there's some way of really validating who's doing it, because it's a PRO, a patient-rated outcome, but a lot of times patients don't understand what the quids is. It's not so intuitive. And if you're just relying on that, you can get pretty shaky data. So you want to make sure that we're collecting data from large groups, but with some type of rigor behind it and consistency. That is what Janssen did. I mean, Janssen, when they set out to get esketamine approved, this is a pretty rigorous set of studies. I mean, you can see this is just for their TRD indication. When you see this, the sample sizes, you can see 52 weeks in duration. That study is now out, as you heard from DJ, out to 4.5 years in duration. I mean, this is rigorous work. You can only imagine how much these studies cost. Does anybody actually know? I can hazard a guess, but it's a lot. More than the NIH or any of the Canadian organizations or European organizations is going to be willing to pay at all to do studies.
The number's 400 to 500 million for those studies.
At least, I think, right?
And that was a year or two ago, but yeah.
Yeah. So, I mean, they're expensive. They take a long time. But I think another lesson that we did learn from these studies, especially from the Janssen studies, I think was you could actually use novel clinical trial designs. And that is very much what Janssen did in their studies. But you have to be prepared to deal with the non-specific effects and the high rates that you may get. So if you look at that data that was done for those studies, especially for the RCT ones, it was giving somebody they had to have a witnessed non-response, which is already pretty expensive. And then they actually compared their treatment. Everybody got a new standard antidepressant treatment. That's not a typical way of doing a study. As an investigator in the study, it was really nice because it's not that, all right, I'm going to take you off all your medicines. You have to be willing to come off your medicines, and you may or you may not get a study drug that we don't know if it works. This is, we're going to give you another antidepressant. I can guarantee you that. And then the question is, will this other study drug on top of it be beneficial? And we're going to test that against the placebo. So it really was a novel design in a way. And it really raises the bar on what you have to beat, because you have to beat the new antidepressant. and not one that you've already failed. It had to be one that you hadn't failed. So you really had to beat a new antidepressant. And if you look at the data from this, I show it for a few reasons. One, just to remind everybody of the data. This was the fixed dose, which was either the 56 or 84 milligrams versus placebo. That was not statistically significant. So that did not hit its primary endpoint because of the way it was set that the 84 milligram had to hit it first before they could even look at the combined or at the 56. But if you look at the response and remission rates, it was pretty consistent and pretty good. I mean, you're getting 50% remission rates, you have 40% response rates. The standard antidepressant did well. It did almost twice as well as you would think one would have from the STAR*D data. You get up to 30% remission rate just with the new standard antidepressant. And I think that talks somewhat to being part of a large clinical trial. The second study was the flexible dose study was statistically significant. It really doesn't look much different, right? In fact, I make the point that it's pretty remarkable how consistent the two studies were. So I really think we did learn a lot about what you're seeing. And if you look at the remission and response rates, again, very similar, but here you're able to see a little bit more of a separation overall. But I think the key point here is if you run these large studies, you really get a sense of what you're looking at. These aren't wildly different studies, or even if you go back to the Repasitol studies, if you look at all those are pretty remarkably consistent. That, what you saw between studies. So these big, large studies give you real data if they're done in a rigorous manner. And if you do look at the long-term effect, I mean, this study was pretty clear. People did well, they stayed well when they stayed in this protocol, either getting once a week or once every other week treatment going out for a year. So I know a lot of people say we don't have much data on long-term, but that's pretty good data. Not great, we'd love to have more. This was, a few hundred people going out. Now we do have it going out much further. All right, but then getting to lesson 9, which I think is what we learned from the studies with ketamine related to MDSI, major depression with suicidal ideation. And this, I think, was also one of the biggest changes to the field that we don't really think of. And actually, Sagar yesterday made a comment saying, well, no drug company will ever fund studies like that. Nobody does it. Actually, we did do studies in real suicidal patients for esketamine, and I'll talk about that. Initially, there was some real excitement when there was some evidence to suggest that in the small trials of IV ketamine, that there was a signal that suicidal ideation was improving, that it was getting better. This is a meta-analysis that was done using individual patient level data. And it was a real signal, but in every one of those studies, having an imminent risk of suicide was an exclusion factor. So none of these patients were really deemed truly suicidal, whatever at risk for suicide behavior. But there was already a signal there. And that gained a lot of traction. And at the time, the NIH had expressed real interest, like how do we start to study real patients that are at risk of suicide? Because to this point, almost every large clinical trial just would have excluded these people. These people would not have been included. But it actually was the case. First, there was a small phase 2 trial done to suggest that you could do this. And these studies were designed with esketamine, where people would come in, and the way we identified people, and we were part of this phase 2 study, we were also part of the Aspire 1 study, they would come to the emergency room, and once it was determined by the emergency room physician that they were going to be admitted, that's when they called us. And that's when they became eligible for screening. Eligible for actual treatment is you had to have actual suicide ideation, you had to have intent, and you had to have a plan, basically. So you had to be really ready to go to the level that required inpatient hospitalization. So these are people that clearly would have been excluded from the study, from any other previous study. And if you look at the data from Aspire 1 and Aspire 2 with esketamine, you see it really does help with their antidepressant effects overall. And that's pretty clear all the way through. We see nice response going through, and they both hit their primary endpoint, which was early response in terms of their overall depression. But And if you look at the actual remission rates, which are pretty amazing. I mean, remission rates of, over 50 or around 50% for two of them at the day 25, a month out. And these are people that came into an emergency room with really imminent risk of suicide. That's pretty good data. But the big problem with this was we couldn't show, or they couldn't show actual benefit in the suicidal component of it. So any of the measures, and the primary measure you see was a CyDAT, was a new instrument that was developed, but it was really hard to show that suicidal ideation or any suicidal behavior. Fortunately, it was hard to show that because there really wasn't much suicidal behavior. But even for the suicidal ideation, people just got better by being in the study. And I remember one of my patients in my study, when I asked them right before getting the dose, because I was the baseline, it's like, well, do you feel suicidal right now? Do you have any thoughts or plans? And he said, you took my shoelace, you took my belt. I have no way I can hurt myself. So no, I'm not thinking about it anymore. So, I mean, it's these unintended things that you don't think about when you're writing protocols, but it's really hard to measure suicidality. It's a very fluid measure to try to catch, and it changes due to so many things. So it's not so easy to do. So anybody who's designing studies to look at suicidal ideation, a big caveat that it's not so easy to do. All right. This is lesson 8 just reinforced that non-specific effects can be very large, and they may actually mask the real drug response. And this is, we were talking before when, I'm sorry, we were talking about the linacimine studies. And so I just wanted to throw this in. So this is the first linacimine study that was done. 150 people, 3 arms, 50 people per arm, using either 100 milligram dose or 150 milligram dose. Pretty impressive. So they were dosed, over the first 3 weeks. They received 3 doses a week for 3 weeks. Both doses separated very nicely from the placebo at that point. And if you actually look at CGI, they did really well. The 100 milligram dose, people did really well, all compared to placebo. Very, very excited at that point. This is an NMDA receptor antagonist, very similar in pharmacology to ketamine, a slight difference in trapping, but otherwise not so easy to differentiate from ketamine. A lot of work was done to identify biomarkers, looking at gamma band oscillations that were similar to the dose of ketamine in both rodent models and also in human models, in humans, where that's where the doses were arrived at. So if you look, but then we go back and replicate that study, 300 people, absolutely negative, just nothing. No matter how hard you squinted at this data, there really wasn't much. I mean, once you start cutting apart where the studies were done, who did the studies and stuff, then there were some signals that popped out. But if you look at this data overall, really nothing. But I just want to magnify it a little bit and show you, the point of bringing this up is, so this was that second study. This was the first study. Just look at that carefully. What's the difference between the two studies? It's that red line becomes this green line. The only thing that changes is the placebo. The drug has the same effect. And in fact, if you look at it, this is looking at the same, because it was the same dose was 100 milligrams used in both of the studies. You could see the actual MADRS score was the same. If you look at response rates, almost identical between the two studies. The only thing that changes is the placebo. So when we were talking about the placebo, I'm not saying that the effect is placebo and everything's just placebo. What I'm saying is that placebo effects are so big, they may actually mask any other effect of the drug. And now we're starting to wind up. Lastly, saying that just because you get into the red zone doesn't mean you're going to score the touchdown. And for some of you that are not American football fans, it's a saying that we use that means just because you get right to the goal line doesn't necessarily mean you're going to score, or at least score the full points. And I think we learned that with ketamine very clearly. We went all the way, all the work was done, got to the point, got FDA approval. Everything looked really promising. But then you try to actually get to these last phases of translational medicine. So, that basic science is to take it from basic science to translational, then from translational to patients and randomized controlled trials. Then you try to translate into practice. Then you actually try to bring it to community settings. And we definitely have stalled out, or maybe not even stalled out. We've caused people to kind of do an end around now because people aren't following the normal path. They're trying to develop new ways of doing this. And this is a paper by my colleague, Sam Wilkinson, who went through and really analyzed how the third-party payers in the US have really pushed this in a way that it's so difficult to actually provide, and the regulatory process. So the REMS that was initiated, the risk evaluation mitigation strategy that the FDA imposed on this, which I think is actually wise and not a bad thing, but it requires that patients receive the treatment in a specific setting, that the pharmacies are registered, that there's tight control over the medication to avoid any use of the medicine outside of the medical realm, that there's healthcare qualified treaters providing the treatment, and that they stay for 2 hours on the premise. That really made it difficult for many providers to do it. So a lot of people did it, said, well, I'm just going to use IV ketamine. I don't have to keep people at all. There's no REMS for that. I don't think that's what the FDA intended when they did this, but that was what happened. So we really have to start to think about, how we can start thinking about the actual implementation much earlier on in the process. Just coming up to 11, starting to wrap it up, expect the unexpected. There was so much back translation. Meaning we went back to the lab, and one of my colleagues, actually one of my fellows years ago, had a great quote that I love. He just said very quietly, he stepped back, he said, psychiatry has done a lot more for neuroscience than neuroscience has ever done for psychiatry. And I think that's just a great quote. And it was that finding, Rob's finding spurred so much basic science. And we learned so much about synaptic plasticity, synaptic density, all spurred on from ketamine. How much it actually describes the true mechanism of ketamine's action, I'm not sure. I'd like to believe it's sort of the foundation of the response, but I think there are so many things that come into the actual clinical response that it's hard to measure, that it's specific to the AMPA receptor, or if it's specific to, the mTORC1 pathway. I think that's really difficult to pin down. And I think that's been evidenced, and Chadi Abdullah was here just presenting his data. So this idea that, well, if mTOR is so critical, if we give a blocker of mTOR in the form of rapamycin, we should be able to block this response, right? And in fact, no, that wasn't what was seen at all. And I think, this is an example of how science should work. So this was a test of the hypothesis that this is, what we would expect to see. Unfortunately, it didn't block it. So we couldn't support the hypothesis. So we can't say this study supports it, but it doesn't really refute the hypothesis either, because we don't really know that rapamycin provided this way actually gets into the brain at the level you need. And Chadi did a really good job of explaining that. But the surprising results was people looked like they may have stayed better longer. And then we come up to the problem of, type 2, issues where this is just the type 2 era. It's small n, and it brings us back to the other part of, if we want to really test this, how do we go back without waiting another 20 years? And the other, I think, unexpected finding that may have really spurred future research is, this was Alan Schatzberg and Nolan Williams' study out of Stanford, suggesting that naltrexone may have attenuated the response, and with the idea that this may implicate the mu opiate receptor. And I think it's possible. Again, it was really small n, and that's, I can just say that for every study, but it's true. It was a small n, hard to interpret too much from. But even if you do believe it, it really raises the question: the actual affinity of ketamine for the mu receptor is pretty low. It's pretty unlikely that this is a direct effect. But I think it is very likely that it is stimulating the endogenous opiate system. And in some way, that is critical to maintaining that response. So I think, it really opens up this other whole avenue of research of how do you study these non-specific effects? Because the other thing that the mu-opioid receptor antagonists are really good at blocking is the placebo or the non-specific effect. So how much of this is endogenous that's generated from hope or whatever other things you want to talk about that's generating this mu activation? And that is critical. It's a critical part of improvement. All right. And really the last or second, the penultimate lesson, set and setting are really important. And this is something I know go back and forth and back and forth. And I just did for the National Academy of Sciences, we just did for psychedelics. And it was like going from one session to another. It was the preclinical where it was all about spine plasticity. Nobody even talked about set or setting. And then go to the clinical and that's all they talked about was science. And it was just like two different worlds. But I think that we're at a point now to deny that set and setting are important. It's kind of crazy. I mean, it's pretty obvious, even if you just look in the rodent models. And I know Polly's still here. I don't know. She mentioned the study that Todd Gould and Ron Duman's lab is they noticed even in the rodents, if it was a female handler, a female experimenter, they got different results than a male experimenter. So that is in some way, I guess, to a rat involved in set and setting. But other work that's come out of Luana Coloca's lab and Todd Gould showing that they can use conditioning, classical conditioning with ketamine, where they treat the rats with ketamine, get this antidepressant-like response, and then all they have to do is bring them back into the cage and they get the response. They no longer even have to give them ketamine. So these are real, I think it's really clear evidence that, set and setting is important. And I think the evidence is pretty clear that how the patient is feeling when they're getting treated, whether they're feeling supported, whether they're feeling compassionate care, those are probably more important than whether it's an NR2B or an NR2E. I think that plays a really large role. And right now we're faced with this because this is becoming such a big issue with the psychedelics. And I think we need to learn from this. I'm really pretty convinced that these have a set and setting have a big impact. What I'm not convinced at all is that we have any clue how to optimize set and setting. I think everybody thinks they have the magic sauce, but I don't see anybody really doing the studies that really would test the hypotheses that they're proposing. And lastly, lesson 13, doing research in ketamine gets you invited to really cool conferences. So I would stick with that. And I really want to thank everybody. And, there are some questions that I think came out, and this was Roger led this effort to come up with this study. And there are clearly major questions that need to be asked and answered. And a group like us, and I know a few of us have already talked, and Allison and others, it would be really great to get together and form some way. And Rupert, you've been trying to get a registry. I've been trying to get a registry. I mean, these are pretty, you think, just common sense things, but almost impossible to do. So hopefully, if nothing else, we come out of a meeting like this with some unified goal of trying to advance the field by getting some collaborative work done. And lastly, acknowledgements to everybody working in the field. All right. Thank you.
Very much indeed, Jerry. Josh.
Thanks for such an amazing summary of the progress. I was curious if you could speak a bit more about what happened after the 2000, that first study, in terms of that lag. I know you alluded to it, but just a bit more detail about, was there sort of projects that were being proposed that weren't being funded or being distracted by other pressing projects? Can you speak a bit more to that?
Yeah, well, I did. I did say so. I know I got interested in it right away. We started to do some animal stuff right away. So I started doing some in the animal lab. And then we did, it was just 2 years later, we started to run that big study. But we were so interested in trying to design. So we probably started designing that within a year. 7 MRS sessions is crazy. Don't do that. That's like really bad. Don't try to do that. The other thing was Rob actually left, right? Rob went to Pfizer, I think, at the time, right? Dennis Charney went to the NIH. So a lot of people that were there doing it kind of left. And Carlos isn't here. He said basically there were other projects that they thought took priority over it. So they were doing some other things first. I don't know, Rob, do you have any other reason why it took so long?
It was also a tough environment to be doing clinical trials.
Oh, I forgot about that.
About the results. including at Yale,
Yes.
I think made us good researchers, but
Yeah.
and so it just was a conspiracy of timing.
I think it was also the will call. It was also the question about ketamine being a provocative. Was that the same timing? Because there was some, I don't know if everybody remembers, but there was some media attention because ketamine was being used as a test of psychosis. And actually, in some cases, was being given to people with schizophrenia, patients suffering from schizophrenia, to exacerbate symptoms. So it was kind of a hot issue at the time. I think that. All right, I think everybody's ready to get home. All right.
It's been a long talk. I feel like I've been here. We've got through a lot. Thank you very much, everybody. I think,